All right, hello people, maths gamers, maths gamers, maths gamers. I'm sure you watched the very first video that dropped. Here's a follow-up video, and I hope you will enjoy it. The question here says, and these are test type questions, as we recap on term one work, and as we build up to the exams that we'll be writing in June, write 33 as the product of two prime factors. Okay, is the product of two prime factors. Now the thing is, in grade 8, whenever we want to write a number as a product of prime factors, what we usually do is we use the trusted ladder method and sometimes the tree diagram. But the whole point of the trusted ladder method and the tree diagram is to actually ensure that we are able to derive from this number that we are given the prime factors. Okay, so we are going to check what is the lowest prime number that goes into 33. In other words, lowest prime number that is able to fit into 33 without leaving a remainder. So we know that that smallest prime number, because our prime numbers are 2, 2 doesn't go into 33 and leave no remainder. The next one is 3. 3 does go into 33, but how many times? So we can take, for instance, what's 33 divided by 3? And we know that is 11. Okay, you could even utilize a calculator there so that you can be able to check 33 divided by 3. What is it? It's 11. Okay, 3 times what gives you 33? It's 11. Then we ask again, what's the smallest prime number that goes into 11? Now from there we can actually see that 2 does not do so, 3 doesn't do so, 5 doesn't as well, 7 doesn't as well, and then the next prime number after 7 is 11. 11 goes into 11 how many times? Once. So when we get here, that's when we know that we are actually done, we are finished, and therefore we can actually stop identifying smallest prime numbers that go into obviously the number that is listed, because 1 is not a prime number, of course. Therefore we can say that 33 is equal to 3 taken from this 3 here times 11 taken from that 11 there, and we've answered the question, because the product meaning the multiplication of what? Of two prime factors. These are the prime factors which when multiplied together give us 33. So that's answered that question, and we can get our 1 mark that we needed there. The next question says the sum of two prime numbers. So in other words, we need to identify two prime numbers whose sum gives us 33. Now, unfortunately for this question, we cannot use the trusted ladder method, but what we can do is we can list the prime numbers that we have: 2, 3, 5, 7, 11. We got 13, 14, 15 is not a prime number, 16, 17, 17 is a prime number, 18, 19, 19 is a prime number, 20, 21, 22, no, 23, yes, 23 is a prime number, 24, 25, 26, 27, 28, 29, 29 is a prime number, and then obviously the trusted 30, 30, 31, 30, 31, 31 is a prime number. So what we basically want to check here is the smallest. What are the two prime numbers when added together give us what? Give us 33, and that's basically what we want. So I'm sure you guys can see that 31 plus the 2 will give us 33. Okay, so that is basically the combination. So 33 is equal to 31 plus 2. That is the sum of the two prime numbers. So here we had to actually list the prime numbers, or at least as per what we ought to be knowing as grade 8 and 9 learners. We need to know the prime numbers from between 1 and 100. And that's very important to be able to identify those prime numbers because it helps us out a lot. And intuitively, I was able to get to this answer. So let's go to, and that's through thought. Let's go to this question. 120 can be written as a product of its prime factors. So let's write down. They want us to write down those, the product of prime factors. So what we can do in grade 8 is we usually use the trusted letter method. Smallest prime number that goes into 120 is 2. How many times does it go? It goes 60 times. Smallest prime number that goes into 60 is also 2. How many times does it go? It goes in 30 times. Smallest prime that goes into 30 is 2. How many times does it go into 30? 15 times. Smallest prime number that goes into 15, you would think it's 2, but it isn't. So therefore we go up a notch and we ask, is 3 a prime number that goes into 15? Yes, it is the smallest even. And how many times does it go into 15? 5 times. Smallest prime number that goes into 5 is not 2, not 3, but 5. 5 goes into 5 how many times? Once. That means we come to a stop. So 120 written as a product of prime factors is 2 times 2 times 2, 3 times 3 times 5. And then we write it in exponential form. How many 2's do we have? 1, 2, 3. So it's 2 to the power 3. Base 2 exponent 3 times 3 times 5. So our 120 can be written as 2 to the power 3 times 3 times 5, right? That is how we write 120 as a product of its prime factors. And it's very important to note that product means multiplication. Multiplication of what? Of prime factors. And this is very specific in that we need to actually write the product as being the factors, okay, of 120, but which are prime numbers, and that's very important. So that is definitely our answer. Let's go and write 90 as a product of its prime factors, as that is the next question. So what we do is we do the same thing. We use our trusted letter method in grade 8, and we write 90. How many times? What smallest prime number goes into 90? 2 goes into 90 how many times? 45 times. And I'm sorry for writing that 0 there. That was not supposed to have even features. So 2 goes into 90 45 times. Smallest prime that goes into 45, I think we definitely have 3. 3 goes into 45 how many times? It's 15. Smallest prime that goes into 15, it's 3. Goes into 5 how many? 15 how many times? 5. Smallest prime that goes into 5, how many times does it go? 5 go into 5 once. And that means that's where we stop, where the 1 is on the right. Then we write down 90. We write down the product of prime factors that we have. We have 1, 2, we have 2 3's, and then we have 1 5, and that's our product of prime factors. 2 times 3 squared times beautiful number 5. The next, last and final question that we're going to look at for now is finding the highest common factor, or as they say, GCF, which is the greatest common factor, which means the same thing, of what? Of 90 and 120. So what's beautiful is that when we have the product of prime factors for each number written in exponential form, then what we can simply do is we can first write down the product of prime factors. And remember, when we want the highest common factor, we choose the base that has, choose the common base that has the lowest exponent. So we look at the two numbers and the product of their prime factors. Then we choose between these numbers the common base that has the lowest exponent for each common base. So we look at the common base, and it has to be common for both numbers. That's how we establish commonality. And then the base means, obviously this is base 2, we have base 2 here as well. That means these are common, but then we choose the common base that has the what? The operative word, the lowest exponent. So between 2 and 2 to the power 3, remember this 2 has a to the power 1, which is unseen. It's there, but we cannot see it. So we choose the base that has the lowest exponent. So that would be 2 to the power 1. That means our base 2, which is common, has been sorted. Then we write as a product and we go to the next base. We have base 2, base 3 and base 3. But this one is raised to the power 1, this one is raised to the power 2. Which one has the lowest exponent? It has to be 3 to the power 1. We are done. Then we identify the common base that has the lowest exponent. Between 5 and 5, they both have to the power 1. So that means we just write one of the bases indicated in our HCF. Then we have the responsibility of multiplying. 2 times 3 is 6. 6 times 5 is 30. So that means the highest common factor between 120 and 90 is 30, and that is that. So guys, this here is a very important question, because highest common factors are things that we are constantly asked to answer in grade 8, right, and in grade 9 as well. But what I'll be doing is I'll actually be doing in the next video how to find the lowest common multiple using the very same product of prime factors of 120 and 90, and we can look at the concept, how different it is from highest common factor or greatest common factor, in that whenever we have our product of prime factors for each number, all we then have to do is choose the common base, and this base has to be common for all the numbers listed that has the lowest exponent. That means if there's a common base, if there's a base that's not common, we don't even consider it to be part and parcel of our highest common factor answer. The bases that we actually choose from have to be common for all the numbers that you are referring to. So if 90 and 120 are the numbers, then obviously we have to check if the particular base is common for both numbers. If it so happens that one of the bases is not common for both numbers, then we do not actually identify that to put it in the highest common factor. And that's very important. I hope this was very helpful. Please drop me a comment in the comment section and let me know what you thought of the video, and if there's anything else that you think would be of benefit for me to cover in the next video.